for attending. My name is Teresa Stratus. I'm a fourth year psychology student. This is my project on alterations in functional connectivity in patients with psychiatric and neurological disorder. And Dr. Blumenfeld has overseen my project. Our lab, actually, I'm in Dr. Blumenfeld's lab, and it's a brain network lab. And our focus is on brain network connections, meta-analysis of fMRIs. We focus on hubs and nodes and a lot of connectivity. So my hypothesis for my project, we're looking at neurological disorders, if they'll have similar connections, the neuropsychiatric disorder connections, and neurological, if they have the different connections and what are the points of centrality. I'm looking for the similarities and differences of the network connections. The specific groups I'm focusing on in the study are Alzheimer's disease, Parkinson's disease, traumatic brain injuries. For neurological and for neuropsychiatric, I'm focusing on schizophrenia, major depression, and bipolar disorder. When I say network connections, and we're looking at how the regions are communicating and how strong the communications are between them, what's the most concentrated areas between the actual brain regions and within these groups. So a traditional approach would be a meta-analysis done by fMRI imaging, and this is a simple fMRI image. But my focus is a functional connectivity and the centrality. So past approaches have used fMRI studies to see what regions are activated and during a given task or during certain domains. The approach of the functional connectivity lets us look at the communication of the connectivity and amongst the region, and lets us study the brain like a network. But the regions of the brain are co-active, so we're looking for the co-activations within the brain regions of the different disorders. So this is, I'm going to explain the network explanation and how the networks work. So this would be region A out of the brain and region B. This is a co-activation. These are activation levels in them, and we want to see where they're connecting. So since this is active right here, and then this one's active, they have the same activation, and then those two have the same activations. As we transition to this next section of the Alzheimer's disease and the Parkinson's disease, we want to find the similarities in regions that they have between each other. So this highlighted area would be something that we would find in our matrices that we're looking at for a deeper look at how they're connected and why, not necessarily why they're connected, but just generally how they connect to each other. So the methods that we use a sleuth database, Excel files, and organizing the Excel files, IPython, which is a coding program that we use. That's a lot for our data output, and graph theory to design our matrices and our nodes and edges. So the process is, this is the sleuth database. This is something that we use to search. So we have our query here with a region. This is for a normal search, so all of the data that we would be getting are for normal subjects, and this is the amygdala on the left side. The database will output this, which is in the workspace, and this is the author, the journal, the domain of the experiment, and then all those numbers on the far side are the number of coordinates inside the data for each paper in the database. We then take this and we put it into an Excel file, and this Excel file condenses everything, and we have to do this for each and every region. We use an atlas called AAL Atlas, and it has an array of 90 different regions. That's for both left and right. We then take all of these Excel files and we put them into a master's list. This master list helps us organize every single paper that we've used. It was over about 5,000 papers, and it lets us put the domain that we're looking for, which is schizophrenia, and all the other domains that we were looking for in this nice master list. This master list will then, input it to IPython to actually code our data. and this is kind of what we get. This is a correlational data matrix, and this matrix shows the significant correlation for our Alzheimer's patients, our Parkinson's patients, our TBI, schizophrenia, depression, and bipolar. The darker the color red is, the higher correlational value that they have between each other. This isn't a perfect matrix, but it's close to what we're looking for with our color patterning. And these values on this side are our values, and they'll tell us the higher it is to 1, the higher the correlational value is. And the lower it is to -1, the less value that the correlation gives us. These are the individual matrices that we use. This is a TBI matrix and the Parkinson's disease matrix. I know it's a lot to take in, guys, but it's just a lot of colors right now. But we're looking at like these dark lines and the shapes that they're making, a very square shape. These two don't have a very strong correlation because you don't see the darker lines that you would like to see. But our Alzheimer's disease and Parkinson's disease show a little bit of a stronger correlational value with this whole box being highlighted up here and then that kind of box being, and then we look right here and right here. And then these numbers on the side are the regions labeled by numbers in alphabetical order for all 90 regions. These are our nodes and edges. So our nodes are points of centrality for each disease, and this would be Alzheimer's disease, Parkinson's, and traumatic brain injuries. The thicker the line is, the stronger the connection is between those regions, and this is at a 0.66 weight for the actual density of the image. So if we were to make it less dense, you would be able to see the nodes behind here as well. These are the depression and bipolar matrices. We see some correlation between them, not a whole lot. It's a very weak correlation. But if we move to the schizophrenia and bipolar matrices, you see this huge correlation to them. I can't tell you exactly why they're correlated, but we just know that the brain regions are active in both the schizophrenia and both the bipolar patients. And these hubs and edges are for our bipolar, major depression, and schizophrenia. The weight for these ones are 0.88, so they have a little more density to them because, as you can tell with the schizophrenia, it's like very dense and you can't really see anything behind it, as well for the major depression. But the bipolar patients, you see it's not as dense, and that means there's a little bit less connections between there. So the data presented shows us that there are connections between the disorders. When we look at the hubs, the nodes and edges of the brain pictures, we saw a lot of concentration with the edges because the edges show how strong the connections are between them. Our neurological disorder matrices show similarities, but not super strong similarities. Our neuropsychiatric disorders were the ones that showed like the strongest similarities in being similar to each other. And I'm in the process of looking about why that is, and we're going to continue like researching into this because all of this stuff is pretty new. And any questions, comments?
Question for our presenter.
Yay! Questions? No? Oh, Jordan.
Are there any disorders that you would have expected to have a high correlation, like between schizophrenia and bipolar?
I would have thought that it would be, I thought that we would see a more correlation in the depression and bipolar because we hear a lot that in bipolar patients that they go through a lot of depression. So that's what I thought I would see when I got the data back, but it turned out to be the complete opposite. The schizophrenia and bipolar patients were closer than the bipolar and major depression. Any other questions? Yeah. Well, for this project, it wasn't really about how they connect, really, but it's really about do they connect? Because this process is not so old. It's a very new process that is very new to cognitive science. So it's more of not really interpreting the data. It's more interpreting the data for face value, not going so deep into it.
Clarification, you said that people with bipolar disorder experience more depression?
No, we hear that they experience depression.
Oh, that they experience?
Yeah, that they experience some depression when having bipolar.
Because they don't have to have a depressive episode.
No, yeah. Oh, hi, Dr. Blumenfeld.
You mentioned what your next steps will be.
I imagine my next steps to be trying to go deeper into the correlation matrix and understanding it a little bit more.
What's your intuition, having worked with this data? What do you think is, what do you think you're going to sort of uncover? What do you think is the reason why you sort of have this sort of surprising result? What's your intuition?
I think my intuition is that the brain is such a complicated thing, and there's so many different things we're learning about it every day, that the connections that we think that we know of are not for face value, that we have to think deeper about it and understand why the connections are happening, or what's different between them, to fully understand why it's happening. So looking at the differences first and then understanding why it's happening. Did I answer your question? Okay.
Yes. Any other questions? Yes.
Yeah, read it.
I think I heard somewhere in the DSM-5 they took bipolar out from depression, they separated.
Oh, really? I didn't hear that.
I thought I heard.
No. And what happens is that often people believe that you have to have a depressive episode
To be bipolar.
to be called bipolar disorder, but you only have to have a manic episode to have bipolar disorder. Right? My fellow
References.
clinical psychologist.
Yes.
Sean,
Sean.
Question, do you think, the positive symptoms of schizophrenia, that is the presence of symptoms that should not be there, like, hallucinations and stuff, might possibly relate to mania?
Maybe in the interconnections of the brain, that might be a reason why they showed such a high correlations in their individual matrices. But we don't know exactly, so that's kind of the interesting part about it, to dig deeper into it.
How would you do that?
Oh gosh, Dr. Blumenfeld. Can I come off the roast chair right now?
Forget about that shit.
I don't know exactly how. Well, I guess task forms and yeah, just doing
Now
the
tell the rest of us what that means.
some follow.
He tells us.
Yeah, Dr. Blumenfeld. No.
Well, I mean, just one of the things about the difficulty in studying this is that you're looking at, to study something like Alzheimer's disease, what we're looking at is brain activity. Well,
Yeah.
these patients are doing tasks. We're not necessarily controlling what kinds of
Tasks they're
they're
doing.
We're sort of looking at everything. So it could very well be that it just so happens that the studies done on patients with bipolar are done in their manic phase.
Yeah.
And that could very well,
Well be.
and that could be something we will look at.
Yeah. We could look at that. Got it. Okay.
Any other questions besides that?
No, we're done.
Great.
Yay!